Problem 6 talks about Arthur, who's going for a run. From his starting point, he runs due east at 10 feet per second for 250 feet. Then he turns and runs north at 12 feet per second for 400 feet. Then runs west at 9 feet per second for 90 feet. Express the straight line distance from Arthur to his starting point as a function of t, the number of seconds since he started. So what this question is basically asking is, at any point t, meaning like if at any point within our domain t, we need to figure out exactly where Arthur is, and then figure out his distance, straight line distance from from his starting point to where he's at t. So for me the easiest way to do this was to do another drawing where he starts at 0, 0, runs east, ends up at 250, 0, then runs north at and then ends up at 250, 400, and then runs east and ends up at 160, 400. And the way I just found these distances was just by using distance equals rate times time, and then, or I guess you could use that formula to find any one of those components given the information we have. And we know that when he gets to this turning point, t is going to be 25. When he gets to this turning point, it's going to be t equals 58.3, and when he gets to the end, he's going to be at 68.3 equals t. So then we need to figure out what his distance is while he's within these lakes. We're going to create a multi-part function, kind of like the baseball diamond problem, if you've done that one yet. And so for the first leg between t equals, or when t is between 0 and 25 seconds, we know that he could be anywhere in here, and to express the distance from his original point to there, it's just going to be an equation of a single line. So it's just going to be d equals rate times time, and then, or really just rate times time equals d of t, and then we can just, we know that his rate was 10 feet per second, so we just do 10t for that leg. And then at some point, or at t equals 25, he's going to hit here and then run up here at a rate of 12 feet per second for 450 seconds. We use distance equals rate times time to know that he lands there at t equals 58.3. Then we find a formula or figure out where he is on here, and then create a formula for the line again. And the way I did that was basically just imagine he was at a point here, draw a line from here, and then figure out what the two sides of the triangle were, and then calculate by hypotenuse, which is going to be our d of t. So in this case, the bottom is going to be 250, and the side is going to be some function of t, but only t since he made his last turning point. So we just use his rate at which he was traveling, which is 12 feet per second, and then multiply that times t, but expressed as a difference from when he made the last turning point. So that's just going to be, oh shoot, where did I write it? 400, oh no, I lost it. Okay, well, it should be something along the lines of 12 times t minus 25, minus 25. And then we plug that into Pythagorean theorem, and then we get between t equals 25 and 58.8, we have, oh, here we go. Here's the triangle, sorry about that. T equals the square root of 250 squared plus 12t minus 300 squared. I just distributed the 12 into the t minus 25. And then for the last leg, we have to understand that he's going to be somewhere in here, but the problem is that makes it difficult to figure out what the bottom is. So what we know is that this entire distance is 250. What we need to figure out is just this portion right here, which is going to be 250 minus this portion right here. Well, we know that he was running at a rate of 9 feet per second, and again, we want to do 9 times t, but t expressed as of an equation from when he was at his last, or as a difference from his last point, or his turning point. So that's going to be 9 times t minus 58.3. So now we do 250 minus 9t minus 524. Again, I just distributed the 9 into, or 58 about. Then that's how you're going to get this little portion. I understood that was going to be the expression for the bottom, and the right was still going to be 400. And then we just use Pythagorean theorem to find the distance here. So that leaves us with the square root of 400 squared plus 774.7 minus 9t squared. So our final answer is going to look like this. It's going to be when t is between 0 and 25, d of t is 10t. When t is between 25 and 58.3, d of t is the square root of 250 squared plus 12t minus 300 squared. And when t is between 58.3 and 68.5, d of t is the square root of 400 squared times 774.7 minus 9t squared.